Good evening, everyone, and thanks for joining us today for the first workshop under Road to Intuition. My name is Varun, and I'm the Vice Chair for IEEE NTU Student Branch. So this workshop series, Road to Intuition, basically aims at teaching tech competencies to participants leading up to our Intuition hackathon, which will be happening next weekend. So this time we've got several big name sponsors such as Goldman Sachs, Indeed, MSD, Google, and GovTech, and you'll have the opportunity to build projects that you can showcase to these sponsors and impress them. So I hope you're excited for that. So today's workshop it is being held by NTUOSS. And for those unfamiliar, NTUOSS is a large student community that promotes open source among NTU students. And it regularly holds workshops, builds projects, and holds school tech-related events. So do check them out sometime if you have the time. And we would like to thank them again for helping us organize these workshops this year. Our lead for today is Astha Garg, who is a year 3 computer science student, and she's the vice chair of TGIFHacks under NTUOSS. She has quite an impressive profile, and she's done past internships at Creative Labs and A-Star. So I hope you'll enjoy the workshop today and learn something under her. Before we start, there are a few quick reminders that I'd like to give out. There will be an attendance form that will be floated across about 20 minutes into the session. So stick around, and when that comes up, do remember to fill that out. Considering that there is limited swag that we can give out to participants, especially considering the online nature of the hackathon, one of the criteria that we'll be using to consider who gets the swag is how many workshops you attend leading up to Intuition and during the event. So do register for as many workshops as you can if you haven't already, and try and attend them. Additionally, if you manage to attend all the Road to Intuition workshops, you will be eligible for exclusive extra swag that other participants won't get. So yeah, another incentive to just sign up and learn a few things this week. Another reminder for the actual hackathon, every team member must sign up individually. So we've seen that for several teams, there are some team members that have signed up and some that have still not yet done it. We won't be making any exceptions once the deadline closes. So if your friends haven't registered for the hackathon yet, then please remind them to do so. This session will be recorded. You must have seen that the recording has been started. And yeah, with that, I'll hand my time over to Astha. I hope you enjoyed today's workshop. Thank you.
Thank you, Varun. Good evening, everyone. I'm Astha, the Vice Chair of TGIFHacks, which is a subcommittee of NTU Open Source Society. And today I'll be presenting the workshop on Git and GitHub for beginners. So we'll just get right into it. So this is the content that we will cover today. First, we will discuss what version control system is. Next, we will see the difference between Git and GitHub. We will see some instructions for installing Git. And lastly, we will go through some of the commonly used Git operations and commands. So let's begin with version control systems. So they are the software tools for tracking or managing all the changes made to the source code during the project development. So what they do is that they keep a record of every single change made to the code. It also allows us to turn back to the previous version of the code if any mistake is made in the current version. So without a VCS in place, it would not be possible to monitor the development of a project. So there will be some words which will be used very often. So I like to describe them. So first is repository. So it is a folder in which all the files and their version histories are stored. The second word is branch. So it is a workspace in which you can make changes that won't affect the live site, that is the main portion of the code. Then the third is markdown. So it is a way to write that converts plain text to GitHub code. So sites such as Atom and Sublime Text are examples of free resources for developers using Markdown. So now I'd like to discuss the two different types of version control system. One is centralized and the other is distributed. So for centralized system, there will be a single central server that contains all the files related to the project. and many collaborators check out files from the single server. So you only have a working copy. The problem with the centralized version control system is that if the central server crashes, then almost everything related to the project will be lost. However, in the distributed version control system, there will be one or more servers and many collaborators similar to the centralized system. But the difference is not only do they check out the latest version, but each collaborator will have an exact copy that is like a mirrored image of the main repository, including its entire history on their local machines. So each user has their own working copy as well as the repository. So this is very useful because even if the server crashes, we would not lose everything as several copies are residing in several other computers. So you can see these two diagrams on the slide to get a better idea of the differences between them. Now we will start with what is Git. So Git is a version control system which lets you track changes you make to your files over time. So with Git, you can revert to various states of your files. So it's almost like a time traveling machine for your code. You can also make a copy of your file, make changes to that copy, and then merge these changes to the original copy. For example, let's say you are working on a website's landing page and discover that you do not like the navigation bar. But at the same time, you might not want to start altering its components because it might make it worse. So with Git, you can create an identical copy of that file and play around with the navigation bar. Then when you are satisfied with your changes, you can merge the copy to the original file. And also you are not limited to using Git just for source code files. You can also use it to keep track of text files or even images. This means that Git is not just for developers, but anyone can actually find it helpful. Next, we'll discuss what is GitHub. So GitHub is an online hosting service for Git repositories. It provides access control and several collaboration features such as wikis and basic task management tools for every project. It lets you store your repository on their platform. So with GitHub, developers can build code, track changes, and innovate solutions to problems that might arise during the development process simultaneously. Now the question arises, what is the difference between Git and GitHub? So Git is a version control tool, that is, it's a software to track the changes in the source code. However, GitHub is a web-based cloud service to host your source code, that is your Git repositories. So we can say that Git doesn't require GitHub, but GitHub requires Git. You can summarize it as Git is installed and maintained in your local system, while GitHub is exclusively cloud-based. So these links can be used for installing Git, and you can follow the instructions. I'll just briefly summarize the instructions. So first, you will have to download the latest Git installer. And after you've done that, you will start the installer and you should see the Git setup wizard screen. When you follow the instructions, you just need to click on next and finish. The default options that are provided for the different configurations are usually suitable for most users. You can also download Git bash if you want. Otherwise, you can just use the terminal. And you will need to configure your Git username and email using the commands mentioned in the links. Due to time restriction, I won't be able to show the step-by-step process. So we will just move on to the next slide. Okay, so before we get into the different operations and commands, I would like to familiarize you with the different stages of a file which are being tracked. So the first one is the committed stage. So when all the changes made to the file have been saved in the local repository, it's called as committed. And files in the committed stage are the files that are ready to be pushed to your remote repository that is onto GitHub. The second stage a file can be in is the modified stage. So this is a file that has some changes made to it, but it's not yet saved, which means that the state of the file has been altered from its previous state in the committed state. Lastly, a file can also be staged, which means that a file is ready to be committed. So in this state, all the necessary changes that have been made are actually made so that you can move the file onto the next stage, that is the commit stage. Okay, so now we will be looking at some of the most commonly used Git operations. The first one being is to initialize a project in Git. So for this, we use git init. So this command creates a new Git repository. It can be used to convert an existing unversioned project to a Git repository or initialize a new empty repository. Now, most other Git commands are not available outside of an initialized repository. So this is usually the first command that you will run in a new project. So executing git init creates a .git subdirectory in the current working directory, and this subdirectory will contain all the necessary Git metadata for your new repository. Now, this metadata includes subdirectories for objects, reps, and template files. A head file is also created, which points to the currently checked out commit. So you'll understand all of this better when we move on and see other commands, but I'll show you the first command, which is git init. So I'll just open my directory and I'm going to create a new folder and I'll call it repo1. So I have Visual Studio Code because many people during the hackathon will be using some form of IDE. So I've chosen Visual Studio Code as it's very versatile. And I'll open my folder here. And I'll start a new terminal. Okay, so now you can see that we are inside our project. I'll just run git init. And you can see that it has initialized an empty Git repository. So let's look at other commands. Okay, so before we look at the other commands, there are again some terms that you should be familiar with. So Git sees every file in your working copy as one of three things: tracked, untracked, or ignored. So if a file is being tracked, it means that a file which has been previously staged or committed. Then there can be untracked files. So a file which has not been staged or committed is called an untracked file. Now there can be files that you need to ignore, which are called ignored files. So Git explicitly needs to be told to ignore certain files. So ignored files are usually build artifacts and machine-generated files that can be derived from your repository source or should otherwise not be committed. So these ignored files are tracked in a special file named .gitignore, and that is checked in at the root of your repository. Now there is no explicit gitignore command. Instead, the gitignore file must be edited and committed by hand when you have new files you wish to ignore. The gitignore files contain patterns that are matched against file names in your repository to determine whether or not they should be ignored. So I'll just give you an example of a gitignore file. Give me a moment. Okay, so this is an example of a gitignore file for React. So as you can see, there are directories like node modules, .pyc, build, .log, .vs code. So all these files are automatically generated when someone will build and execute your code. So you don't need Git to track these files. And these files also may have some sensitive information which is specific to your local system, which you don't want to reveal to others. So you can ignore the files by mentioning that in this .gitignore. Okay, so now we are going to create a repository in GitHub. So for that, first you need to create a GitHub account, because to be able to use GitHub, you will have to create an account, which you can do at this link. Then you can create a repository and add and commit files. So I will show you how to do that. Okay, since I already have a GitHub account, I will show you how to create the repository. You can click the plus sign, and I'm going to create a new repository. I'll just name it new repo. I'll also add a README file. So this is written in Markdown. And you can see that GitHub provides us an option to add a gitignore when we are first creating our repository. So if you click on this, it also gives you a list of templates that you can use. For example, if you're making a Unity game, then you can just scroll down to Unity here. And like if you select this, then it will initialize the gitignore file with the most basic files that are to be ignored. But we won't be doing that, so I'll uncheck this, and we are going to create a repository. So this is a blank repository that we just created on GitHub. So the next thing is to connect the repository to GitHub. So we will connect our local repository to the remote repository. So for this, we use the command called git remote add, and we'll give a name and the repository URL. So what this command does is it creates a new connection to a remote repository. And after adding a remote, you'll be able to use the name as a convenient shortcut for your URL in other Git commands. Generally, we use origin as the shorthand name for the remote repository. So let's try doing this. I'll go back to my VS Code. And okay, so before that, I will get the repository URL, which I can do from here. I will be using SSH because I have configured my terminal with that. I can click this to copy the URL. I'll go back to my terminal and just write git remote add origin and paste. Okay, so now my local repository is connected to the remote repository. Okay, so now this is how you can create, you can connect your local to your remote repository. But what about your other teammates? So they can use the command git clone to copy repository from GitHub. So this is primarily used to point to an existing repo and make a clone or copy of that repo in your new directory at another location. So as a convenience, cloning automatically creates a remote connection called origin, pointing back to the original repository. This makes it very easy to interact with the central repository. You can also add other arguments like branch so that you can clone just a specific part of the code instead of the main part of the code, which we will see later on. So I will try to clone the repository that we just made into another directory. So I have actually created a folder called cloned, and I will be cloning it here. So I'll go back to my VS Code and open that folder. Okay, I'll start a new terminal. So I'm inside the cloned folder. I'll go back here and copy the URL. Sorry, I missed the G. Okay, so now you can see that I have the new repo here, and it has the README file that we had added earlier during the initialization of our repository. So I will change directory to the Europe. Okay. Now we are going to see other commands. Okay, so for inspecting a repository, we usually use the command called git status. So this command displays the state of the working directory and the staging area. It lets you see which changes have been staged, which haven't, and which files aren't being tracked by Git. So status output does not show you any information regarding the committed project history, and status messages also include relevant instructions for staging and unstaging files. So let us try running this command for our repository. Okay, so you can see it says that our branch is on main and it's up to date. That is because we haven't really made any changes. And there's also nothing to commit, and our working tree is clean. That is again because we haven't made any changes. Okay, so before moving on to the next command, let's just add a few files. So I'm going to add the text file. I'll call it txt1. Okay, and I'll just add a line saying this is the first text file, let's say. Okay. I'll also add another file called text2. And I'll say this is the second file. And we'll save this. Okay, so now we need to add files to our Git. And so for that, we use two main commands called git add dot and git add file name. So the period or dot that comes after add means all the files that exist in the repository. So if you want to add a specific file, then you need to use git add and then the file name. Or if you want to just add all the files, you can use a dot. So after executing this command, your file will be in the staged state. You will not get a response after this command, but to know what your file, state your file is in, we can run the git status command. So let's try adding the files. First, I will add only the text1 file. So you can see that we did not get a response, but we can check the status with the git status command. Okay, so now you can see here changes to be committed, that is the staged changes, show that a new file text1.txt has been added. And then you can also see untracked files, that is text2.txt. And this is so because we haven't added it yet. So I'm just going to run git add dot, which will help me in adding all the untracked files at once. Now we will again check with git status. Now you can see that the changes to be committed include both these files. Okay, now since our files are staged, the next step is to commit them. So for that, we use the command called git commit -m and then the message. So the first part of the command, git commit, tells Git that all the files that are staged are ready to be committed. So it is time to take a snapshot. Now the second part, -m message, is the commit message. -m is shorthand for message, while the text inside is the actual message. Now, I would like to advise you all to be very meaningful when writing Git messages, because when multiple people are making a lot of commits, it will be easier to know what changes were introduced in which commit if you have meaningful messages. So now let's try committing these two changes. So I'm going to run git commit. This is the first commit. Okay, so now I'll run this, and you can see that it shows me that two files have been changed. There are two insertions. that is text1 and text2. So okay. So now, since we have committed the changes to our local repository, the next step is going to be pushing these changes to our remote repository. So for that, we use the command git push origin, because you remember origin is the shorthand name that we had assigned. So the command is used to upload local repository content to a remote repository, and pushing is how you transfer commits from your local repository to a remote repository. So let's try doing this. Sorry. Okay, so now you can see that it has pushed our changes to GitHub. So I'll go back to my repository and refresh. Now you can see that it shows that this is the first commit, and you can also see the 2 text files that we just uploaded. So now our changes from the local repository have been pushed to the remote repository. Okay, so now the way that we can see all our commits is using the command git log. So what this command does is that it shows us the commit logs, and there are different flags that can be used. So for this, you can go through the different flags. The ones that I have listed are the most basic ones, but we'll try running git log and see if we can check our commits. Okay, so as you can see, we have 2 commits. Initial commit, this was created when we first initialized our repository. And this is the first commit. So this is the message. It also has a hash. And you can also see the author, the date when the commit was made. So git log helps us in seeing all the commits that we have made. Okay, so now syncing changes from remote. So let's say your other team members have made some changes to the remote repository, and now you want to sync those changes to your local repository. So for that, we use these 2 commands called git fetch and git pull. So the fetch command downloads, I just want to confirm, is everyone able to see my screen properly?
Yep.
Okay. Okay, so the fetch command downloads the commits, files, and reps from a report repository to your local repo. So fetching is what you do when you want to see what everybody else has been working on. However, the pull command combines the fetching with the downloading. So it will fetch and download the content from your remote repository and immediately update the local repository to match that content. So the git pull command first runs git fetch, which downloads the content, and then a git merge is executed to merge the remote content into your new local merge commit. Okay, so I will make the change over here so that we can see how git fetch will work and git pull will work. I'll just add a line called edited on GitHub and create a new commit. So I'll just call it committed on GitHub, and I'm going to commit these changes. Okay, so now these changes have been committed. If I go back, you can see the latest commit. Now I'll come back to VS Code and I'll just write git pull. So now you can see that it has pulled from my remote repository, and you can see there are insertions and changes made to the text1 file. So if we go to text1, you can see the edit that we made on GitHub, that is edited on GitHub, which was a new insertion. Okay, moving on to the next. So this is a very important part of using Git and GitHub, that is branches. So branching means you diverge from the main line of development and continue to do work without messing with that main line. So you can either merge these changes to the original copy or just let the branch remain independent. So as you can see in this diagram, it's just multiple commits which are connected. So for creating a branch, you can use the git branch command with the branch name. So it will create a new branch, but it does not check out that branch. That means it won't switch to that branch. It will just create it. And if you want to list all the branches in your repository, then you can use the git branch command. So let's try doing that now. I will run git branch. As you can see, we only have one branch right now, which is the main branch. I will now create a new branch and just call it new branch. So now a new branch has been created. If I again run git branch, you can see it lists both these branches. Now main is highlighted because that is the branch I'm currently on, and the newly created branch, new branch, is also listed. Okay, so now for using the branch, we use the command called git checkout branch name. So switching branches is actually a straightforward operation. Executing the above command will point the head to the tip of the branch name, which is already existing. So if you want to create a new branch and immediately switch to that branch, you will use the next command called git checkout -b and the new branch name. So the -b argument acts as a convenience method, which will create the new branch and immediately switch to it. So you can work on multiple features in a single repository by switching between them with git checkout. So let's check out the new branch that we created. Okay. So now we have switched to the branch called new branch. If I again run git branch, you can see new branch is highlighted because we have shifted to that branch. Okay, so before merging, let us make some changes to our new branch. So for that, I'm going to go to text to file and I'll just add this is change new branch and I'll save this. Now I'll run git status. So you can see that we have modified this file. So now we need to stage the changes and commit. So first I will run git add. So now my changes have been staged. If we run git status again, you can see that these have been staged and now need to be committed. So let's create a new commit. And I will write the message as committed in the new branch. So now you can see that we have made the file change. Okay, so now this change was made in our new branch, but it does not reflect in our older branch, that is the main branch. So let's see how we can do that. So we can use the command called git merge and give the branch name to merge the changes made in the new branch with the main branch. So this is used to combine two branches. Git merge takes two commit pointers, usually the branch tips, and will find a common base commit between them. So once Git finds a common base commit, it will create a new merge commit that combines the changes of each queued merge commit sequence. So what Git does is that it automatically determines the merge algorithm. The merge commits are unique against other commits in the fact that they have two parent commits. When creating a merge commit, Git will attempt to automatically merge the separate histories for you. However, if Git encounters a piece of data that is changed in both histories, it will be unable to automatically combine them. So in this scenario, there is a version control conflict and Git will need user intervention to continue. So let's try merging first. So for merging, first I need to switch my branch to the main branch. So I'll just do git checkout main. Now you can see I have switched to the main branch, and now I will run git merge new branch. That is my new branch name that I want to merge with my main branch. Okay, so in this case, we did not get any conflict because there were no changes in the main branch that conflicted with my new branch, since the new branch only made additions. So since we are in the main branch, let's create a new commit by editing text1 and saying changed in the main branch. And we are going to, and we're going to save this. And again, we will run git status. So you can see it has been modified but not staged. So let's add this first. Then we are going to commit. Let's just call it changed in the main branch. Okay, so we've added this new commit. Now we are going to switch to our new branch. Okay, so now we are in new branch. You can see that txt1 does not have the text that we added. And now we are going to add another line here so that we can actually create a merge conflict. This is the new branch edit, and I'm just going to save this. So again, we need to commit this first. I'll quickly commit this. Okay, so now we have edited the same piece of data in both the branches. So if I switch to my main branch and I try to merge the branches, you will see that we will get a merge conflict. Okay, so as you can see, it says auto merging text and it found a conflict. So now, as soon as it finds the conflict, it's going to stop the merging and remain in the conflict stage. So let's see how we can resolve this. Okay, so if the two branches that you are trying to merge both change the same part of the same file, Git won't be able to figure out which version to use. So when such a situation occurs, it stops right before the merge commit so that you can resolve the conflicts manually. So when Git encounters a conflict during a merge, it will edit the content of the affected files with visual indicators that mark both sides of the conflicted content. So these visual markers are, as you can see on the slide. So generally the content before the equal to marker is the receiving branch, and the part after that is the merging branch. So a very simple way to handle merge conflicts is to open the file in your editor, edit the file as you desire, and remove all the conflict dividers. After that, you can stage and commit the edited files, and Git will know that the new contents needs to be merged. So let's try doing that. I'll come here. So you can see in txt1, I have this change. So let's say I want to keep the new branch edit and get rid of the main branch edit. I will just delete this and keep the new branch commit. And I'm going to save it and create a new commit. Okay, so now our commit has, we have made the commit and the merge conflict has been resolved. Now, since we have added all these commits, We would also like to push these changes to GitHub. So I can just do git push origin. Okay, so now it's done. If we actually go back to GitHub and refresh, you can see the change. Okay, let's go back to the slides. Okay, so another important thing that you will be using is stashing the changes in Git. So we use git stash for that. So the git stash command takes your uncommitted changes, both staged and unstaged, saves them away for later use, and then reverts them from your working copy. So at this point, you're free to make changes, create new commits, switch branches, and perform any other Git operation, then come back and reapply your stash when you are ready. So you need to note that the stash is local to your Git repository and they are not transferred to the server when you push. So let's try making some change and stashing them. I will just add a line called we will stash this change and save it. So you can see it's modified. I will run git status again to show you the modification. And now I will run git stash. So now you can see the change we made has actually gone. That is because we have stashed that change. And now we can create new commits or make any changes that we want. And whenever we want, we can reapply the changes from the stash. So let's see how we can do that. So for applying the stashed changes, we can use two commands called git stash pop and git stash apply. So when you pop your stash, it will remove the changes from your stash and reapply them to your working copy. So whatever changes you had stashed will be removed and deleted from the stash. So you won't be able to retrieve them after they have been applied to your working copy. Alternatively, you can also reapply the changes to your working copy while keeping a copy of those changes in your stash. And for doing that, you can use the git stash apply command. So this is useful if you want to apply the same stashed changes to multiple branches. So you can use git stash apply in one branch, then switch branch, and then apply those changes again. However, if you do git stash pop, then those changes will be removed from the stash, so you won't be able to apply them in any other branch. So let's apply the changes that we just made, that we just stashed. So I'll use git stash pop because I don't need to apply them elsewhere. You can see that this line got added because we just popped our stash. So it added this back. Okay, so now we will see how we can undo changes in Git. So for that, we can use git revert. So the git revert command is used for undoing changes to a repository's commit history. So a revert operation will take the specified commit, inverse the changes from that commit, and create a new revert commit. So the ref pointers are then updated to the point at the new revert commit, making it the tip of the branch. So reverting should be used when you want to apply the inverse of a commit from your project history. Now, this can be useful, for example, if you're tracking down a bug and find that it was introduced by a single commit, instead of manually going in, fixing, and committing a new snapshot, you can use git revert to automatically do all of this for you. Now we are going to see how we can reset in Git. So this is again a very important operation, and it's very important to use this also well and be very cautious. So the git reset command is a complex and versatile tool for undoing changes. It has three primary forms. These forms correspond to command line arguments: soft, mixed, and hard. And the three arguments each correspond to the Git's three internal state management mechanisms that we will discuss now. Okay, so the three trees are working directory, staging index, and commit history. So the first tree we'll examine is the working directory. So this tree is in sync with the local file system and is representative of the immediate changes made to the content in files and directories. The next is staging index. So this tree is actually tracking the working directory changes that have been promoted with git add to be stored in the next commit. Now this tree is, okay, so the next one is commit history. So commit history, we know when we run git commit, it adds the changes to the permanent snapshot, and those changes live in the commit history. So now using these three trees, we'll see how git reset works. Okay, so when we are resetting, you can see at the surface level, actually, git reset is similar in behavior to git checkout, where git checkout solely operates on the head ref pointer. Git reset will actually move the pointer to the current branch pointer. So you can see this example that you have multiple commits A, B, C, and our head will be pointing towards C. When we do git checkout, our main remains there, our just head moves. But when we do git reset, the head and main both move to the commit that we chose. So comparatively, git reset moves both the head and the branch refs to the specified commit. So the three arguments that I had stated earlier, hard, mix, soft, are described here. So what hard commit does is that the commit history ref pointers are updated to the specified commit, then the staging index as well as the working directory are reset to match that of the specified commit. The mixed one is actually the default operating mode, and in this, the staging index is reset to the state of the specified commit. Any changes that have been undone from the staging index are moved to the working directory. And the last one is soft. So when the soft argument is passed, the ref pointers are updated and the reset just stops there. The staging index and the working directory are left untouched. So now I'll discuss the difference between clone and fork. So forking is done on the GitHub account, while cloning is done using Git. So when you fork a repository, you create a copy of the original repository, but the repository remains on your GitHub account. Whereas when you clone a repository, the repository is copied onto your local machine with the help of Git. Changes made to the forked repository can be merged with the original repository via a pull request. So what pull request does is it lets the owner of the repository know that you have some changes which can maybe fix some bugs or improve the code. And so the owner can merge your request as and when he or she wants. So on the other hand, changes made on the local machine can be pushed to the repository directly, as we have already seen. So forking is a concept, while cloning is a process. So forking is just containing a separate copy of the repository, and there is actually no command involved. Cloning is done through the command git clone, as we had seen earlier, and it is a process of receiving all the code files to the local machine. There is a GUI client, that is a graphic user interface client for Git, which is very popular, called GitHub Desktop. You can go to this link to download it. So it is an application that allows you to interact with GitHub using a GUI instead of command line or a web browser. You can push, pull from, and clone remote repositories with GitHub Desktop and use collaborative tools such as attributing commits and creating pull requests. So I will just show you what it looks like. So this is GitHub Desktop, and we can actually add our existing repository. So you can see that the change that we had applied from the stash is seen here. So you can see the insertion and it shows the modified file. If you can just create the commit from here. So let's just say update it from GitHub Desktop. So this is basically our commit message. Now we are going to commit it to main. So now this has been committed. If we want to push it back to our repository, then we can just do push origin. So we'll just wait for it to complete. Okay, so now this has been pushed. I will take you back to our repository to show that it has been actually pushed. So you can see updated from GitHub desktop. So if you are not comfortable using the command line, then you can also use this GUI client. So I will also like to discuss some of the best practices for using Git. So firstly, you should make clean single purpose commits. This can be useful because if you fix a bug or if you added a new feature and you commit those changes, then you don't have the risk of losing other changes in case something goes wrong. You should always write meaningful commit messages so it'll be easy for you to track the progress of the project and also go to a specific commit to look at some changes that you want to. You should commit early and commit often. That means that you should not wait for too long to make a lot of changes and then commit, because it can actually, for example, if you run into a bug, then it might be difficult for you to backtrack all the changes you made. You should not alter published history, because if you are working in a project with multiple team members, then it can be difficult to track the changes again if you alter the history itself. You should not commit generated files. That is, you should make good use of the git ignore file and ignore the files that are automatically generated when you build and run your code. So you can also contribute to open source projects on GitHub. So this is just a list of the steps that you can use. So first you'll have to fork the project, then you can create a new branch. You can make some commits to improve the project, push this branch to your GitHub project, and then open a pull request on GitHub. So after you discuss the changes with the project owner, it depends on the project owner to merge or close the pull request. And after that, they can sync the updated master back to your fork. This is a list of some helpful resources which you can use to learn more about Git. And there's also a cheat sheet which actually states some of the most commonly used operations and commands. So with that, we come to the end of the workshop. If you have any questions, then please let us know. Thank you.